Let's look at yet another variation for the mine placements for the Minesweeper game. We are enhancing the Minesweeper project from the Byte Python curriculum. You notice in the mine field, I've got a 9 cross 9 here with 10 mines, but there is this pink color cluster, which is for me a high density cluster. In fact, it turns out that there are 7 mines out of 10 which are inside this cluster. So, when I play this, let's say you see, I click on this, a lot of things open up. I know this is a mine. I'm just going to click on this just to demonstrate what I'm trying to say. You notice that 1, 2, 3, 4, 5, 6, and 7 mines out of 10 are in fact in this cluster. So, this is what we are going to build next. Let's look at it again. This time down, the cluster is different. The location of clusters is different, but let's say I try playing this. Obviously this will open up quite fast when I click on this just to reveal all the mines. Once again, you notice 1, 2, 3, 4, 5, 6, 7 are inside this 5 cross 5 and 3 are outside. You can try this yet again. This time the cluster location is different. So every time the cluster location itself is different, but there is a 5 cross 5 area in which I have 7 mines. So when I click on this, very sparse, so things open up. I'm just okay, let me just click on this so that the mines are revealed. Again, you notice there are 7 inside this ring. So this is what we are going to build. Once again, a very nice useful programming exercise in how we index these lists. The clues are correct, but the location of this cluster keeps changing, and we make sure that there are more mines in this cluster than outside. So nice programming exercise, and hence I thought I will bring them in here. And in fact, solving it also becomes quite difficult because this area is actually quite dense. We'll see this in a moment. So like I said, the whole idea is that we are going to identify a 5 cross 5 cluster of squares. Now 5 is just a number. Depending on the size of your grid, you might choose some other dimensions for this. But let's say 5 cross 5 squares, which has, for example, let's say 7 mines. Now again, this is just your choice. You can also change this. So depending on the game that you're doing, but to get the idea. Now the whole idea is that, look, I need to identify where this 5 cross 5 region can be. This region is being picked up randomly, but obviously for a 9 cross 9 grid, for example, the leftmost corner, and that's what called a starting square, the leftmost corner of the square must fall inside this region. Now this is a little bit like how we approached our Connect 4 project, where we identified where could I start, let's say, a winning combination from for the different situations. Now in this case, since I'm looking at a block of 5 cross 5, you can argue that it must be inside this, because the last possible position is really the square where I can form this 5 cross 5. So I'm just looking at the topmost corner of the square, and I'm saying that, look, it must fall in over here. Having identified this corner, I can then figure out what are the, let's say, rows and columns that are involved. Again, that's by fact. Important to understand, however, that this is being done for a 5 cross 5, and the reason it's going from 0 to 4 is because the grid itself is 9. So let's say the grid was larger, say 12, then it would have gone to 0 until maybe 7 or 8, right? So the point is, in order to determine this region, we will not be doing 0 until 4 on both x and y. In fact, we'll be doing n calls minus 4 and n rows minus 4, because we are looking at a 5 cross 5 square. Again, think about it. Very interesting point. Now the approach we are going to follow is that, like I said, we are going to first figure out a starting square for this random range, and that square obviously must fall inside, let's say, this set of squares. Having found this, we will identify the squares that are part of this cluster. So for example, if I would choose, let's say, this square over here, say 3 3, then the cluster is somewhere here, right? And depending, if I choose 0 0, then this itself is a cluster. So wherever it starts, accordingly there are squares in the cluster. We'll identify that, and we will convert these all into locations so that the program keeps running, because remember, locations are going from 0 until 81, right? Or say 80 in case of 9 cross 9, right? Now we will pick n cluster locations from within these locations, and the remaining locations we'll put from the remaining squares. So that way I'll be sure that n cluster mines, for example 7 mines, are densely placed within this cluster area. Also, for recognition, we will give a different color to the squares in this cluster so that we can easily identify them. So the very nice logical approach. Let's see this in code so that it becomes a bit more clear. So I get back to my first thing first. I'm going to create a new variable here. I'm just going to call it, say, cluster placement. is equal to true. Now, you can explain what this means. Also, I'm going to set the balance placement to false so that, the two can't go together, right? Because when I'm putting in cluster, it's different from putting in balance, right? So in fact, I could have said cluster placement is not a balance placement. That's okay. I'm just setting up a new variable here, cluster placement. Now, obviously, all of this has to happen inside place mines because the clues are going to work exactly the same. But before, getting there, let me update my variant label so that it's clear. I'm going to just say instead of balance placement, I'm going to say, well, cluster placement. Now, so I get back to my place mines function. Remember, I've set the balance placement to false. In fact, I'm going to just create one more of such conditions. Say if cluster placement is, let's say, true. So, I'm looking for a certain cluster. So if it is indeed cluster placement, I need to now figure out where I can start the clusters. Now, let me just, let's say define a variable. So let me define a variable called say cluster size. Now, again, I'm assuming it's the same size on rows and columns, but you can make this. So I'm saying it's going to be a 5 cross 5 grid. You can create two variables if you want to do it differently. Um, Basically, C star cluster. So this has to be randomly chosen, but remember I'm going to exclude the last four columns from my let's say from my columns because cluster size is 5 for me. So the way I'm going to do this is random dot choice. Say create a list. So x for x in range 0. So actually n calls minus 4. Now, of course, I could have used also random.random. That's perfectly fine. But I'm going to also define in the, so this should be actually, let's do it properly, cluster size minus 1. And in fact, the same way I'm going to put, let's say, for the row, just that row will be n rows and everything else remains exactly the same, and this is going to be basically r plus r start cluster. So basically, so at this point I know where I want to start my cluster and I've ensured that it's in a good spot. Recall, the cluster must start within this grid, and that's what I've done. Now, having determined the start for the square, for example, let's say the start is 1 1, we know that the starting square is inside this grid. Now we will determine what are the squares that are actually part of this cluster. Now, the way we are going to do this is, well, we know that this is starting point. I'm going to be looking at 5 rows, including this row, starting from here. So that's 1, 2, 3, 4, 5, or say 0, 1, 2, 3, 4, and likewise 5 columns. So 0, 1, 2, 3, 4. So basically these will be the squares, assuming I'm starting at 1, 1, to be, let's say, in my cluster. But remember, I want to represent them as numbers. So I'm going to use, let's say, the number variation. So remember, this is 0, this is 9, this is 18, this is 27, and so on and so forth. So this particular number is nothing but 9 plus 1. So, essentially I'm just doing number of rows times the row index, and that tells me what is the, the base location here, and then I can count how much offset. So like I said, having found the C cluster and the R cluster, I'm going to, create, basically I'm going to just create a bunch of lists. So I go and say locations is, let's say, an empty list. I create another list here called lock cluster, also an empty list. Now basically all the squares that are part of the cluster will end up in this lock cluster, and I can do this with through like a nested loop. So I just go and say idx in range, let's say cluster size, because like I said, starting from that row 5 rows and starting from that column 5 columns. So that's exactly what I'm doing. So I just go and say for idx in range cluster size, and let's say another let's say for kk in range also, say range, let's say cluster size. So basically both rows and columns, I look in both directions, and what I do is to just take lock cluster dot append. And what do I append to this? Well, like I said, we want to append the location And that can be done by, now that can be done by saying n calls times r cluster size plus index, because notice this is going through the different rows, and then I must offset for the column. And the way I do that is by just saying, well, plus, let's say plus, c start cluster plus kk. Now so it basically, that's like getting to the leftmost column, which is this, on every row, and then offsetting for the column index for all the 5 columns. So that's exactly what we are doing. So that becomes my location cluster. So basically these are all the cells that will be part of the cluster. Now I want to be able to select, let's say, a large number of mines from this. So I can use, for example, so I can go and say, well, locations dot extend. Now we'll talk about this, why we are using extend over here. I'm going to say, well, random dot sample, well, lock cluster, and let's say 7 mines. So basically what I'm trying to say is that, look, there is this 25 square cluster, pick up 7 mines from there. Now remember, random dot sample will give me a list of 7 items, but I want to add them item by item into my locations, and that's why I'm using an extend, not an append, because if I did an append, that entire list will become an item. So that's not what I want. I want to add them item by item. That's why I use extend. Now having done this, now I want to select those locations that are not part of this cluster. So I'm just going to create another list here called lock, let's say, others, and we can use list comprehension for this purpose, quite useful. So I'm just going to say x for x in, you know um, so x for x in range, range, say, n rows times n. That is nothing but the entire field, like we were doing earlier. That's the locations all. However, I will exclude those which are part of this cluster, so that way I'll be sure that I'm not picking up any more from the cluster, because this cluster things have already been chosen earlier to this. And the way I do that is adding a condition by list comprehension by saying that, look, if x not in lock cluster, so basically if it's not a part of this cluster, then add this to the location others. And having done this, I'm going to use a similar command over here. So I just go and say, well, location dot extend, let's say lock others, and say 3 mines. Now again, this 7 and 3 also could have been variables. So n mines is being assumed as 3. So maybe I'll just put 7 here, and then I can put, let's say, n mines, uh, you know, mines minus 7. So that 7 are in the cluster and remaining are outside the cluster. Now, just one more thing we need to do, which is that I want to highlight these, the location of the cluster. So I just write a new function here. Let's just call it highlight, let's say, cluster, and I give it highlight cluster, and I just give it, let's say, the cluster locations. So that is basically lock cluster as the argument. I just write a new function here, def, let's say, a highlight, say, cluster. Now the way we will do this is actually quite similar to how we were handling the locations earlier. I can, my location cluster contains those x and y values. Um, my my location cluster contains all the locations. So I'm just going to run a for loop. I'm just going to say for locks in, let's say, lock cluster, which is being passed as an argument. Also, this should be an argument here. Lock, say, cluster. So for this, which is coming as an argument to me, just run a for loop over this. Convert from this number to an xy grid, and we can do that by just saying, well, lock xy is, well, div mod locks and n calls. Now, having converted this to, say, the XY grid, I am going to just say that, okay, look, those buttons must become pink in color. And I can do that by just looking at my list called buttons, say lock XY0 and lock XY1 dot config bg equals to, for example, pick. So that way, those so this way, those inside the cluster will be highlighted, and it's easier for me to know where are the high density clusters. So let's see this in action now. So there was a small syntax error here, which I fixed now. This, notice I get this cluster placement. Let's say I start with a 9 cross 9 grid with say 10 mines. When I click create, you notice there is this pink color area, so I can make this a bit. So when I run this game, you notice there's a cluster formed here. Let's just try to get to the mines. Okay, a lot of things open up because there's hardly anything outside. Let me just click on this to make sure everything is the way I wanted it to be. Indeed, there are 3 outside and there are 7 inside this. Let's try to reset this. You notice this time the cluster location changes, but still it's a valid cluster. Let's try to solve this one this time. So it gets quite interesting. I click on this, not very lucky. I click on this. Yes, indeed, I have some luck here. Let me, try to mark the mines here. So this is clearly not a mine. This is not a mine. This is not a mine. None of this is a mine. So this opens up. In fact, this has to be a mine because there's 2 here, and I know there's only 1 mine outside, so it must be this. I can randomly click anywhere, and I'm sure there's not a mine. But here I have to be careful because I know there are lots of mines here. So I'm just going to click on this to be a mine. This is not a mine. So there are 4 over here. There's 1, so this has to be a mine. So that covers my 2. This is then not a mine. This is then not a mine. So if there's a 4 over here, well, these 2 must be mines. 3 is taken care, so this is not a mine. One of these 2 is a mine. Now notice this is actually gets quite hard because very dense over here. This is, however, not a mine. Okay, so let's see. So I've got, okay, so 1 and 1 here. So this must be a mine. And if this is a mine, this is not, because there was a 2 over here. Now there's 4, so one of these 2 has to be a mine. Can't tell exactly which one it is. Let me see if I can guess from here. So I know that one of these 2. So I know that exactly one of these 2 is a mine. And I also know that exactly one of these 2 is a mine. So, it's kind of a little bit hard to guess which one exactly is. I'll have to take a chance, I guess. So I'll take a chance. Okay, so I was unlucky. Indeed, both of these are mines, but you get the idea that it's quite hard now because very, very dense. And we have got 3, 4, 5, 6, 7 mines here and 3 mines in there. Now again, these are just numbers, but clearly the game becomes more interesting as we play this. So if I, let's say, do this again, this time the cluster is elsewhere. Let's just try to find out all the mines again. 7 and 3. So quite interesting. The game. At YByte, we always build activities and think of enhancements, implement these enhancements, because that is a great way to learn programming. Look at our website www.ybyte.in. You will find that there are many, many, many such activities through which we learn Python programming. Take care. Thank you so much. Bye bye.